Hello and welcome to another exciting chemistry session. This is your host, Mr. Wansa, your chemistry tutor. Today we're going to look at lesson 4 and lesson 4 under atomic structure. We're going to talk about what we call an ionic structure. An ionic structure. So under ionic structure, we're going to describe uh, what an ion is. We're going to describe a cation and an anion. Then we're going to learn how to write an ion or an ionic symbol. All right, so uh, we're going to describe what an ion is. So what is an ion? What is an ion? So an ion is a fully charged particle. An ion is a fully charged particle. When an atom happens to lose or gain uh, electrons or an electron, it is deemed to be called an ion. So an ion is just a fully charged particle. So an atom is bound to lose or gain electrons, and then it will be called an ion. Remember, according to the atomic structure, we say an atom is a neutral species. So an atom on its own, it's neutral. But when an atom loses or gains an electron, then the name changes from an atom, it becomes an ion. So the key words here is losing and gaining. So when an atom gain or an atom lose electrons, then it changes its name to an ion. So an ion is just a fully charged particle. Now, there are two types of ions. So there are two types of ions. The first one is called a cation, and the second one is called an anion. So what is a cation? A cation is a positively charged ion. So an ion with a positive charge is known as a cation or a cation. Then the opposite of it is called an anion. But just to give more details about uh, uh, a cation, allow me to use whiteboard so that we can, yeah. So we're saying we have what we call a cation, and we have what we call an anion. Okay, so a cation, we are saying it is a positively charged ion, a positively charged. So a positively charged, then we have a negatively charged ion. So a cation is a positively charged, and anion is a negatively charged ion. What makes a cation? So a cation is as a result of losing, electrons. Then what is an anion? An anion is as a result of gaining. So how do we form a cation? A cation is where a particle loses electrons. So both particles are either losing or gaining electrons. Both are either losing or gaining electrons. So what loses? So what loses? So what loses is called a metal atom. A metal atom will lose electrons. And then what gains electrons? What gains electrons is known as a non-metal atom. And the key question is, where do we find these same metals and non-metals? So cation, positively charged ion. How do you form a cation? By losing electrons. What loses electrons? Metal atoms. Anion, negatively charged ions. How are they formed? By gaining electrons. What gains electrons? Non-metals. So when you go back to the slide, they're talking about the cation. What is a cation? It's a positively charged ion. This is formed when a metal loses electrons. So metals lose electrons according to its valency. So we have what we call the valency number. We'll soon talk about it. We have what we call the valency number. So below electrons, metals lose according to the group they belong to on the periodic table. So we're going to look at the periodic table, and then we'll see how these we'll see how these elements are arranged on the periodic table, and then we're going to see which ones are metals and which ones are non-metals. So here we're talking about group 1, they lose 1 electron. Group 2, they lose 2 electrons. Group 3, they lose 3 electrons. Group 4, they lose 4 electrons. But we're going to give more details about the meaning of the statement. Then we have an anion. So like earlier explained, an anion is a negatively charged ion. How is it formed, or what is involved? So what is involved is a nonmetal. So a nonmetal will gain electrons according to its valency. So we have what we call the valency number. So below are electrons, nonmetals gain according to the group they belong to on the periodic table. So we have group 4, they gain 4. Group 5, they gain 3. Group 6, they gain 2. And group 7, they gain 1. So atoms lose or gain electrons in order to achieve stable electronic configuration in accordance with duplet or the octet rule during the formation of ions. Then metals lose electrons while non-metals gain electrons. So we're going to explain the meaning of the duplet and the octet rule as we go on this particular series. So our interest is anion and cation. So how do you know that these are metals, and how do you know that these are non-metals? So allow me to just go to the periodic table. So I'm just going to use a rough sketch of a periodic table. So a periodic table, so if you have a periodic table with you, allow me to use my whiteboard so that I just explain a few things on the periodic table. So according to the periodic table, we're going to have groups, not drawn to scale. Just want to explain a few things. So we have this, and then it extends from there, extends from there. We have okay, so 3, 4. Erase this part. 3, 4, 5, 6, 7, and 8. So we have what we call groups on the periodic table. We have what we call groups on the periodic table. So we have group 1 in Roman numerals, group 2, then we have group 3, we have group 4, 5, 6 there, Roman numerals, we have group 7, like that. Then we have group O, which is also known as group 8. Then down here, allow me to put what we call the valency number. So what is the valence number? The valence number is just the combining power of an element, just a number, which comes as a power, combining power of an element. So we have group 1. In group 1, that is where you find sodium, lithium, rubidium, cesium, francium. You go to group 2, you find beryllium, you have magnesium, you have calcium, you have barium, and so on and so forth. Now, here, our interest is in group 3. So in group 3, we have B, which is boron, and below we have aluminium. We have aluminium. Now, between those two elements, I want the colorful, okay, and this thickness. Between those two elements, we have this. So this is called, so you can try it on your periodic table. This is called the zigzag line. This is called the zigzag line. What this zigzag line does is that it separates metals from non-metals. So this is called the zigzag line. Zigzag line, or they call it the aluminium step. So on the right side of the zigzag, this is where you find all the non-metals. This is where you find all the non-metals. All the non-metals, you find them on the right side. Then on the left side, this is where you find all the metals. This is where you find all the metals. So remember, we said, what do metals do? Metals lose. What do metals do? Metals lose. Then what do non-metals do? What do non-metals do? Non-metals gain electrons. So the gaining is not just unnecessarily, but the gaining is according to the valency number, the combining power. So it's our responsibility to know the valency number of each respective group. So each respective group we have to know the valency number. So valency number for group 1, all the elements that are found in group 1, their valency number is 1. Group 2, the valency number is 2. Group 3, the valency number is 3. Group 4, the valency number is 4. Group 5, the valency number is 3. Group 6, the valency number is 6. Group 6, the valency number is 2. And group 7, the valency number is 1. So you'll notice that the valency number will begin to decrease from group 5. So it will be 3 to 1. So 1, 2, 3, 4, 3, 2, 1. So non-metals, they gain. Metals, they lose electrons. Now, what is so special about metals is that when they lose electrons, when metals lose electrons, they possess a positive charge. They possess a positive charge. When non-metals gain electrons, they possess a negative charge. So this is a very important information that we need to understand. So know the valency numbers of each respective group, and then know if that element in that particular group is a metal or it's a non-metal. There are a lot of questions that come on this particular concepts. So when you look at an element, are you able to tell if it's a metal or it's a non-metal? Does it have a positive charge? Does it have a negative charge after losing or gaining electrons? So those are very important things that we have to take care or take note of. Sorry. So the other thing is the zigzag line between boron and aluminium. We have the aluminium step. So you follow your periodic table and make that zigzag line. So on your right or to your right, you have non-metals. Then to your left, you're going to have metals. So this is the information that we're going to use in the next concept. In the next concept, we are required to know how to write an ion. And this is basically what they're talking about. So first thing, know the atomic symbol. So they're going to give you an element. For instance, write the ionic symbol for potassium ion. So potassium ion. The question is, do I know the atomic symbol? So the atomic symbol for potassium is capital K. Can you locate the atomic symbol on the periodic table? So you check the periodic table and find K, capital K is potassium. Know the group to which this particular atom belongs to. So potassium belongs to which group? If I check on the periodic table, I notice that potassium belongs to group 1. Do I know the valence number for group 1 elements? So according to what we did on the whiteboard, you know that the valence number for all the group 1 is 1. Then know whether the element is metal or it's a non-metal. Then writing of ionic symbols. Writing of ionic symbols, we're going to make use of the formula shown there. So X representing the atomic symbol. Then on that atomic symbol above, you're going to indicate the valency number. So just allow me to So to write the ionic symbol, symbol. First and foremost, I have to know the atomic symbol. If I know the atomic symbol, well and good, then on top, that is to the right top, I'm going to write a superscript valency number, a superscript valency number of that particular atomic symbol, and then I'm going to put the charge. I'm going to put the charge. Is this particular uh, atom, is it a metal or it's a non-metal? So if it's a metal, I'll put a positive charge. If it's a non-metal, I'm going to put a negative charge. So this is the most important information that we need to understand when it comes to the writing of ionic symbols. So when it comes to the writing of ionic formulas or ionic symbols, it is very important for us to know the periodic table, because we rely so much on the periodic table, as it gives us all the information that we need. So we have to take note of the valence numbers of the respective elements, and then we'll begin to write. So for instance, they asked me to write, okay, allow me to clear, okay, let me just clear everything. For instance, they asked me to write the ionic symbol for potassium. For potassium, I'll start with the cations. Potassium, not potassium atom, but potassium ion. So potassium ion. So if I check my periodic table, that is, potassium is found in group 1. Potassium is found in group 1. So when you check group 1, you're going to note that the valence number for group 1 elements is 1. Therefore, according to the rules, we have to write the atomic symbol for potassium, which is capital K. Then, what is the valence number of potassium? When you go on the periodic table, you find that valence number for potassium is 1. Then you ask yourself, is potassium on the metal side or the non-metal side? So you check your zigzag line. So the zigzag will tell you that potassium is on the metal side, therefore it carries a positive charge, and you cannot say 1 positive. So 1 positive is the same as positive. So this is what we call potassium ion. They ask you to write aluminium ion. What is aluminium ion? If you go on the periodic table, you look for aluminium, you find it in group 3. Aluminium is capital A, small l. What is the valency number? So we're using the formula atomic symbol, valency number, brackets just, and then we are putting the charge. So the charge tells us if it's a metal or non-metal. So what is the valence number for aluminium? You know that aluminium is coming from group 3, therefore its valence number is 3. Is it on the metal side or the non-metal side? So it's on the metal side, therefore it will carry a positive charge. So this is called aluminium ion. They can ask you to write for calcium ion. So you can pause the video and see if you can write for calcium ion. Calcium ion, when you go on the periodic table, the atomic symbol for calcium is capital C, small letter A. In which group? It's coming from group 2. What is the valence number? For group 2, as 2. Is it on the metal side or the non-metal side? So it's on the metal side, therefore it carries a positive charge. So all these are examples of cations. Remember, cations, we said positively charged ions, positively charged ions. So basically that is what we do when we are formulating ions of positively charged ions, which are known as cations. Now let's look at anions. How do we come up with anions? Remember, we said anions are negatively charged. So anions involves non-metals only. Non-metals only. Now, there's something special about anions. When we consider them in atomic state and in ionic state, we'll notice that their names will be different. So their names, they change by getting the suffix of DE. In other books, they say IDE. So we'll notice that the oxygen atom, what was called oxygen atom, when it gains electrons, the name changes to oxide. So it carries the IDE. What was called fluorine, when it gains an electron, the Ne changes to De, so it becomes fluoride. So fluoride ion is different from fluorine atom. So these are atoms, and on the right side you have what we call ions. Sulfur changes to sulfide. So that is the behavior of the nonmetals. They change their suffix when they become ions. So when we look at oxygen atom in its neutral state, it's just oxygen with 16 and 8. It doesn't have any charge there. It means that it's neutral. The P is equal to the E, if you remember. Now, when we talk about oxide, so what happens when this guy called oxygen gains electrons? What happens when the oxygen gains electrons? So what is the symbol for oxygen? So oxygen is O. What is the valency number? So you check the group where oxygen comes from. So oxygen comes from group 6. Group 6, what is the valency number? 2, correct. So you put a 2 there. Then is it on the metal side or on the non-metal side? So it's on the non-metal side, correct. Now, what is the charge for non-metals? So the charge is negative, correct. So you put negative. So this now is called oxide. It's no longer oxygen because it has gained 2 electrons. So very soon look at how to find the PEN in ions. For now we just want to learn how to write. What about fluorine? Fluorine atom is F19, 9. If it's an atom, it doesn't have any charge, so it's neutral. Now what happens when it gains electrons? So what is the symbol? So it's capital F. What is its valence number? So it's coming from group 7. Therefore, when you check the valence number for group 7 elements, it's 1. Is it on the metal side or on the non-metal side? So if it's on the non-metal side, then it should carry a negative charge. So to remove 1 negative means negative, so we just put negative. So this is what is called a fluoride. This is what is called a fluoride. So what is important about anions is that they lose according to their valence number. So you have to know the valence number for you to determine the ionic symbol. And the key thing to take note of is that the name changes. It adopts IDE on the suffix. So the oxygen becomes oxide, fluorine becomes fluoride, chlorine becomes chloride, sulfur becomes sulfide, phosphorus, phosphide. So we'll get to hear those names: bromine, bromide, iodine, iodide. So we get to know the nomenclature, which is just a naming system uh, of those particular ions. So that is on the cations and the anions. Basically, that is how we write the ionic symbols and the for anions and cations. So cations, they lose. What loses? Metals. Anions, they gain. What gains? Non-metals. And then we go into the writing of the ionic symbols. So basically that is what we needed to know on the anions for today. So we'll continue talking about anions in the next section. Uh, Otherwise, this is what we had for today's session. This has been your host, Mr. Monsa. Until we meet next time, bye bye.